When we're working with numbers, there's always a digit in every place. This number, for example, has no tens, but it has a 0 in the tens place, because the place is the only thing that indicates what place each digit is in. On the other hand, in this polynomial that has 0 x's, there's no need for a 0x to hold the place, because the exponents on the x's already indicate what place everything is in. However, the long division algorithm requires that we keep the places lined up, which means that if we have gaps, we need to fill them in with zeros. Otherwise, we won't be able to line up for our subtraction. So if we want to do this example, notice our dividend here has no x squared term. When we write that in our division bracket, we need to fill in a 0x squared in order to hold the place. We'll see why that's necessary as we proceed with the division. So we'll proceed with the division one place at a time. We'll take divide first. So 8x to the third divided by 2x is 4x squared. 4x squared will be the first term in our quotient. Next we multiply. 4x squared times 2x minus 3 is 8x to the third minus 12x squared. So 8x to the third minus 12x squared. Now we subtract. 8x to the third minus 8x to the third is 0. 0x squared minus negative 12x squared minus negative 12 will be positive 12x squared. Bring down the negative 28x. Okay, now notice, if we hadn't had this 0x squared here, there would have been nothing to write the negative 12x squared under. We would have had nowhere to put that, and so we wouldn't have been able to proceed with the long division. All right, next, we divide again. 12x squared divided by 2x is going to give us 6x. Positive 6x is the next term in our quotient. 6x times 2x minus 3 will give us 12x squared minus 18x. 12x squared minus 18x. Now we subtract. 12x squared minus 12x squared is 0. Negative 28x minus negative 18x is negative 10x. Bring down the last term. Divide one more time. Negative 10x divided by 2x is negative 5. Negative 5 will be the last term in our quotient. Multiply. Negative 5 times 2x minus 3 is negative 10x plus 15. Negative 10x plus 15. We're subtracting something from itself, so we get 0. In this problem, it happens we have no remainder. Again, the only thing that's different here is that we need to fill in that x squared term. We might also need to fill in missing terms in the divisor. So notice here our divisor 2x squared plus 3 has no x term. Again, in order to make all of our columns line up, we need to fill in a 0x. That way in our multiply step, we'll still be able to line things up. So, divide first. 2x to the 4th divided by 2x squared is just a 1x squared. The first term in our quotient is x squared. So x squared times 2x squared plus 0x plus 3 is 2x to the 4th plus 0x to the 3rd plus 3x squared. 2x to the 4th plus 0x to the 3rd plus 3x squared. Notice, having this 0 term here, make sure that the 3x squared is in the right place. So now we subtract. 2x to the 4th minus 2x to the 4th is 0. Negative 6x to the 3rd minus nothing is negative 6x to the 3rd. 11x squared minus 3x squared is 8x squared. Bring down the next term, negative 9x. Okay, divide. Negative 6x to the 3rd divided by 2x squared is negative 3x. Multiply negative 3x times 2x squared plus 0x plus 3 is negative 6x to the 3rd plus 0x squared minus 9x. Negative 6x to the 3rd minus negative 6x to the 3rd is 0. 8x squared minus 0x squared is 8x squared. Negative 9x minus negative 9x is 0. Bring down the 12. I forgot to actually write the term in when I divided, but I can look at where I wrote that down. One more round, right? We'll divide 8x squared divided by 2x squared gives us 4. Last term in our quotient is plus 4. 4 times 2x squared plus 0x plus 3 is 8x squared plus 0x plus 12. And now we subtract. We subtracted something from itself. We got 0. Again, we have no remainder.